relax, sit back and listen to our math class. In today's class, we are going to do this problem. Here matrix A and B has been given and we have to find the matrix X such that this condition has been given. Okay, by using this condition, we have to find the value of X. Before approaching this problem, we have to know, we should have an idea about properties of matrix addition. So, matrix addition has four properties. It will satisfy four properties. It will satisfy the commutative law, associative law, and that matrix will have an additive inverse and there will be an additive identity. So, first one, commutative law. Commutative law means this A and B are matrix. So, A plus B equal to B plus A. And the matrix A and B will be of same order. For example, matrix A order is M by N means matrix B order will be M by N. And it will, if you are adding these two matrix A plus B, then that will be equal to B plus A. This is the commutative law. Next, associative law. According to associative law, you will have three matrices. These three matrices will have same order, and A plus B plus C means that will be equal to A plus B plus C. Here, we first added this A plus B and then with that A plus B we have added this C. That will be equal to, here first we have added B plus C and then we have added this A. So, this A plus B plus C equal to A plus this B plus C. Next, existence of additive identity. Additive identity means here matrix A has been given and if you are adding this A with 0 matrix, this 0 denotes 0 matrix. So, if you are adding any matrix with this 0 matrix, then you will get that matrix itself. So, A plus 0 equal to 0 plus A equal to A. Next, existence of additive inverse. So, here our matrix is A and I am adding this matrix with the negative of A. So, I will get the 0 matrix. So, there will be an additive inverse for every matrix. There will be an additive identity. So, with the help of additive identity, you will get that matrix itself. In addition, additive identity is 0. Associative law means first you are adding these two and with that answer you are adding this C. Here A plus B plus C. So, matrix A will be here plus first you are adding this B plus C and with that B plus C you are adding this A and these two are equal. Next, commutative law means A plus B will be equal to B plus A. Here in these two laws the order will be same. Here only one matrix is used and that matrix when added to a 0 matrix you will get that matrix itself. Here that matrix and negative of that matrix will be equal to the 0 matrix. Now we are going to solve this problem. Matrix A and matrix B has been given. Then find the matrix X such that condition has been given 2A plus 3X equal to 5B. By substituting the values, the matrix A and B in this equation, we are going to find the value of X. Before that, first we can simplify this equation. So, 2A plus 3X equal to 5B. If I am adding minus 2A on both sides, I can reduce this 2A. Am I right? So, 2A plus 3X minus 2A equal to 5B minus 2A. We have we wrote minus 2A on both sides. And we already know that matrix addition is commutative. Now only we saw the properties, right? So according to a commutative property, A plus B equal to B plus A. So we can that this A plus B will be equal to B plus A. So we can change the position of the matrix. So here we can change it 2A minus 2A plus 3X equal to 5B minus 2A. Since matrix addition is commutative. 2A minus 2A will give you 0. plus 3x equal to 5b minus 2a. So this 0 denotes the additive identity, and this minus 2a here act as additive inverse. Minus 2a is a additive inverse. So 3x equal to 5b minus 2a. So x equal to 1 by 3 5b minus 2a. Now we can substitute the value of b, matrix B and matrix A in this equation, and we can find the value of the x. So x equal to 1 by 3 5 b. B is 2 4 minus 5 minus 2 2 1 minus 2 into A. A is 8 4 3 0 minus 2 6. First we can do scalar multiplication. So we can multiply this 5 with each and every entry. 5 2s are 10. Here minus 10. 5 4s are 20. 5 2s are 10. 5 5s are 25. 5 1s are 5. Minus again 2 8s are 16. 2 into 0 0. 2 4s are 8. Here minus 4. Here 6. Here 12. Now we can do subtraction. Okay. So 1 by 3 into this 10 subtracted with this 16. So 10 minus 16. Here this minus 10 with this 0. Minus 10 minus 0 and 20 with minus 8. So 20 minus 8. Next 10 with minus into minus 4. Next minus 25 with 6. Minus 25 minus 6. Next 5 with minus 12. Okay. So 1 by 3 into 10 minus 16 minus 6. Here minus 10. Here 20 minus 8 12. Here 10 minus into minus plus. So 10 plus 4 14. 25 minus 25 minus 6 31. Minus 31. Here minus 7. Further x can be rewritten as, we can multiply the scalar with each and every entry. So minus 6 by 3 minus 10 by 3 12 by 3 14 by 3 minus 31 by 3 minus 7 by 3. So what you will get? Minus 2 4 minus 31 by 3 minus 7 by 3 14 by 3 minus 10 by 3. X equal to. This will be your final answer is. So here overall concept is, we have solved this problem by using the properties of matrix addition. So matrix addition will satisfy commutative law, associative law, and it has additive inverse and additive identity. Additive inverse is inverse of that negative of that matrix, and additive identity is 0. Okay. And now before solving it, actually we have to find the value of x. So we have further simplified this equation, and then we substitute the value of a and b here. In this problem, we found the value of x by using the properties of matrix addition. Thank you for watching. Subscribe to our channel for more videos related to both school and college maths. Thank you.